Welcome back to the channel guys. In today's video I'm going to explain you 5 very important Java interview questions which were asked in Amazon. Believe me, in this video the questions which I have covered is super important for any SDET interview and in fact for any company. It will be a short revision session and a knowledge gaining session for you all. This video can be a little longer as I am going to explain the answers as well as the concepts of Java which are required to solve the problem. So by the end of this video, I give you my words that you will be able to tackle complex Java interview questions, and this video is free to watch. I just need your attention to stay till the end so that you can be an expert and crack more interviews. So without wasting any time, let's get started. So here in the screen you have your first question. The interviewer will ask you that you have to explain wait, notify and notify all. These are the three functions which are there in Java. But before going to the answers, let me explain you what this function actually means and why these functions are important. Alright, cool. So let's come back to a new page and let me take a marker. And first of all, let me tell you that these three concepts of wait, notify and notify all, these are related to multi-threaded programming in Java. Alright, so it's an advanced concept in the Java which tells you about multi-threaded programming. Alright, and multi-threaded programming is a feature of Java that differentiates Java from other language. For example, in other language probably you have only one thread, right? So what thread means? Thread means it is a small piece of CPU that executes your program. So imagine if you have only one thread which executes your program, it means you can process only one class at a time or one program at a time. But imagine if there is a case that you have more than one thread, probably 2 threads or 3 threads or 4 threads or like 10 threads, what will happen? You can process 10 different classes or 10 different programs at a time. That means Java will be much faster than other language. So if you are in a multi-threaded programming environment, it's a benefit for you that you can process more line of code in just shorter period of time. So this is what entire process of multi-threading called. Now there are 3 terms: wait, notify and notify all. We are going to understand this term in detail. Alright, cool. So first of all, you have to understand if you are working in Java, Java works on object. Alright, so for example, you created a new object, a object called as car probably. So car is your class and you created an object, let's say O1, which is equal to new car. So this is how you create an object in Java. Now O1 is your object. Okay. First thing that you have to remember that every object has its own lock. I will write this down for you, and this is the most important point that you have to explain this to the interviewer. Every object has its own lock. Now what does lock actually means and why is it important, right? So since I was telling you that we are in a multi-threading environment, okay, and for multi-threading environment, locks are a very important part of it. Why? Let me explain you. For example, I tell you that we have multiple threads. Let's say thread T1, thread T2 and thread T3. So we have, let's say, 3 threads in our CPU that are working, and I have one object in the heap memory. So this is my heap memory. This is my heap memory, and I have an object O1 which I have just created and it is lying inside somewhere in the heap memory. Now what will happen? Let's say the thread T1 comes and the thread T1 changes the value of object O1 to be, let's say, since we have a car, so T1 sets the value of object O1 to be an Audi. So the car, T1 is saying that the car should be Audi. Next, T2 comes, T2 changes the object value to be BMW. Okay. And again T3 comes and T3 changes the value of object O1 to be probably Ford. Alright. So these three threads are there and these three threads can access this object and they can change the value of the object. Now imagine a situation. We are inside a function. Okay. And we are in the process of changing the value of object O1. So this inside this function, T1 is in the process of changing. It is just at that time T1 was changing the value of object to be Audi. And at the same instant, at that exact same instant, T2 came and T2 started changing the object to probably BMW. And for example, if some user is there and if a user try to get the value of that object, now what do you think? What will be the value of that object? Is it Audi or is it BMW? Right? That's where the problem lies. So what will happen if at the same instant two different thread comes and try to change the value of that object? There is the problem in multi-threading environment. And to solve all of this problem, we have something called as lock in Java. This lock is sometimes also called as monitor lock. Okay, monitor lock. Now how do this monitor lock works? Okay, let's take a very simple example of a bathroom probably. Alright, let me change the color. So let's take a very simple example of a bathroom. So for example, you are inside a bathroom. Okay, now what happens when you are inside the bathroom? You will have the key of that bathroom, right? And no one can enter in your washroom or in your bathroom. That means now you have the access to the lock of that bathroom and no other guy can come and interfere your privacy. In a very similar manner in Java, the concept of lock work. So now how do we solve this problem? We have object O1. Now as I told you that every object has its own lock. So now O1 has its own lock. What T1 will come? T1 will come and T1 will acquire that lock. Okay, T1 will acquire that lock and start changing the value of object O1 to Audi. Okay, now since the T1 has acquired the lock, T2 and T3 cannot come and change the value of object O1 to BMW or Ford. That is the concept of locks, right? I hope you are getting it right. So now there are two concepts of wait and concepts of notify. Now what will happen, since the T1 is acquiring a lock, there can be a new problem that can arise. To solve that problem, we have this wait, notify and notify all. So where do we start? We started from the initial problem. Initial problem was that in a multi-threading environment, the problem was that anybody can access and change the value. To solve that problem, what do we introduce? We introduce the concepts of lock. Now in the concepts of lock, there is a new problem. And let me explain you the new problem. Let's come back here. So the new problem is, for example, we have thread T1 and we have thread T2. Thread T1 is, let's say, the producer and thread T2 is, let's say, the consumer. And when I say producer and when I say consumer, it's just the data. So T1 is producing the data and T2 is consuming the data. As simple as that. Nothing big in this. Alright. Now imagine a scenario. Where T1 is producing the data and T1 has stopped producing. T1 has stopped producing. It means the data, due to some reason, the reason can be anything x, y, z, due to some blockage or due to exhaustion of data, T1 has stopped producing the data. Now T2 comes and now T2 will see that T2 have to consume, right? Now T2 will see that there are no more data to consume. Now what will T2 do? T2 will simply wait, and it will wait until the new data is produced. Now do you understand, while the T2 is waiting, what can be the new problem? While the T2 is waiting, it is actually using CPU, and it is actually using memory, right? Because now T2 is still up and T2 can still use the CPU and memory while it is waiting for the producer to produce more data. So to solve this problem that T2 does not utilize this extra memory, we have something called as wait function. Alright. So now what will wait function do? So now wait function will tell the thread T1 that please release the lock. Please release the lock. Okay. Wait function will tell the thread T1 that please release the lock and free the CPU. So since T1 was not producing any data due to some reason, now since we have wait function already written, T1 will release the lock, and now the object O1 is now free. So probably if we have some other thread T3 or probably T4 who wants to access this object and do some changes, he or she can come and do the necessary changes while T1 is ready to produce more data, right? Where this is where the wait function is useful. All right. Now after some time, imagine T1 start producing the data again. T1 start producing data again. So once T1 start producing data again, we use notify function to notify other threads like T2 that okay, I am producing the data again. And now you can come and consume my data, right? And at last notify all. This is important because this will tell all other threads. It will tell thread T2, T3, T4, and if you have some more thread as well, it will notify all the threads that okay, I'm ready to produce more data. Now you can come acquire and consume more data. So this is the difference between wait, notify, and notify all. Let's just go through what's written in the screen, the typical answer. So it must be called inside synchronized block on the same monitor. So basically the object which acquires the lock is under synchronized, the code is always written in the synchronized block. So wait releases the monitor and suspends the thread. Notify or notify all wakes up on all waiting thread, which then content to reacquire the monitor lock. Always loop on a condition, okay, to handle spurious wake up. So and here is the difference of notify and notify all, which interviewer can also ask you. So what is notify? Notify is basically one random waiting thread who wakes up, and notify all is all waiting thread, or it will notify all the waiting thread. What is the risk of deadlock in this? It is higher because if wrong thread is chosen, then it's a deadlock. So for example, if T2 was consuming the data from T1, but T1 notified thread T3 that okay, I am ready, so T2 will still wait because no one has notified T2 that okay, you come and consume the data. So that's a deadlock. And T3, and if we have notify all, then it will notify all other threads, and okay, if anyone wants to come and consume the data, everyone is welcomed. What is performance? Faster, only one wake up. So since you have to notify only one thread, so obviously notify will be faster and notify all will be slower. And when to use? So if you have when only one thread should be awakened, like single consumer, then you use notify. It's a very common sense of question. When multiple thread may need check, it will check the condition. All right. So this was our first question. I hope you have understood. If you have still any doubt, you can still comment down and I reply to all the comments. You can write it to me and I will reply it to you. So without wasting any time, let's move ahead to our second question. Alright. So in our second question, we are talking about thread pool and executor. So the interviewer will ask you that what are thread pools and executor, and what and why and how do you resize them. Alright. So before understanding why and how, let's understand what. What is a thread pool and what are executors. Then we will understand what is why thread pools are required and how thread pools can be resized. Alright. So let's come back to the new screen, and let me tell you, thread pool is nothing but just a group of threads which we can create, right? So for example, you have a CPU, okay? You have a CPU and you have a program that you need to run. You have certain line of program. Let's say you have 10,000 line of program. Okay, and you have certain functions inside it. Now you decide that to run this 10,000 line of program, I need probably 3 threads. Okay, it's up to you how many threads you want to create. If you are creating more thread, then obviously your program will be faster, and if you are creating less thread, your program will be slower. And obviously it depends on how do you utilize them as well. It doesn't really matter that you create 10 or 20 threads. If you know how to use your threads efficiently, then even you can in 5 threads you can get a performance of better than 10 threads if you know how to use it efficiently. So for now, let's imagine we understand how to use threads efficiently, and we have created 3 threads. Okay, so I have created 3 threads to run this program. So thread pool is nothing but just the collection and the grouping of 3 threads. So we have a pool like this, and inside this pool we have a thread T1, we have a thread T2, and we have a thread T3. And now all these threads are available to execute our program. Imagine it as a restaurant. Let's say you own a restaurant over here. Okay, probably you own a very big restaurant, and inside your restaurants you have 3 waiters. Okay, 3 waiters. Now imagine few guests are coming. So how this waiter will handle the guest? The first waiter will go and ask the guest that okay, what is your order, and he will again go back to the kitchen and give the order. Now the waiter 1 is free after he has taken the order and given the request. Okay, now this is free to go to other customer as well. Similarly, thread 2 or waiter 2 or waiter 3 can go and ask some other guest and go back to the kitchen. So as soon as they are working, after every asking and after every request to the kitchen, the waiter gets free. So if you have probably 100 guests, if you have 100 guests, you don't need 100 waiters, right? You don't need 100 waiters. 3 might be enough so that they can work on 100 guests once they get free. So you don't need to create a new waiter or a new thread every time for a new task. So this is what our thread pool is used for. Alright. So imagine you have certain tasks to do. In this 10,000 of line of code, you have, let's say, 50 tasks that you need to perform. So this T1, T2, T3 will perform task one by one, and as soon as they get free, they will pick up another task. It is as simple as that, like how you work. So once you finish your task, you can pick up your another task like that. So this is what a thread pool is used for, and this is what a thread pool is. Alright, so basically what is the advantage of thread pool? That you don't need to create a new thread every time you have a task. So if thread T1 and thread T3 is busy and thread T2 is free, you can use your thread T2 for a new task. It can be reused. It's basically reusability. Alright, this is what a thread pool means. And what is the need of a thread pool? That you don't need to create threads, because creating thread is really very expensive in the sense, in case of memory, you need lots of memory to create a new thread. And one more important part, if you answer it this point to the interviewer, he or she might get impressed if you tell him that thread pool can queue tasks if all the threads are busy. For example, if thread T1 is also busy, thread T2 is also busy, and thread T3 is also busy, and you have more tasks line up, right? So thread pool has the ability to queue the task. So as soon as the thread T2 will get free, now the task will be again assigned to thread T2. Until then, this thread pool will queue the task in a queue, right? Okay. Now comes the next question, that how do you actually create a thread pool, right? So to create a thread pool, you have something called executors. So the statement in Java to create a thread pool is like this. You use a class called executor service. Executor service, and you create executes, which is equal to executors dot new fixed thread pool, and inside this you pass the number of thread you want to create. So in my case, I want to create 3 threads, so I pass 3. So this is the statement which is useful in creating a thread pool. So executor service is the class, and you define like this, and you can create a new thread pool. Trust me, if you just explain this statement to the interviewer, and you are hired. That's it. So this is how you create a new thread pool. Now, one thing I want to tell you, that there are 4 types of thread pool that you can create. The first type of thread pool is what I have just created right now, is a fixed thread pool. Okay, fixed thread pool. Number 2, the second type of thread pool which you can create is cached thread pool. Number 3, the third type of thread pool which you can create is single thread pool. Okay, and last, one more type of thread pool which you can create is scheduled thread pool. To create all of this thread pool, you just need to replace it over here. I'll just tell you where I have written just this fixed thread pool. If you just replace this fixed thread pool with a cached thread pool and a single thread pool and a scheduled thread pool, you can create all the types of thread pool. What are the differences in all the types of thread pool, and where do you use them? Let me tell you. Fixed thread pool, as you all know, we have just created that if you want a fixed number of thread, let's say I know that my program need only 3 threads, so I can use fixed thread pool and I can pass the number that I need 3 threads. Cached thread pool is basically your unlimited threads, which is very expensive, by the way. Unlimited threads. So let's say you don't know how many threads do you want. So in that case, you create a cached thread pool, and the single thread pool, with the name you can understand, to create only one thread. If you just need one thread, you create a single thread pool. And at last, scheduled thread pool, which is rarely used. So this thread pool is created to have a periodic function. So if you want to create threads in a certain period of time, after every certain period of time, then you use this scheduled thread pool. All right. And the last question, how do you size them? Very simple. Just remember this formula. This is the formula to size a thread pool. Okay, so the number of thread is equal to number of CPU you have. So basically 1 core, 2 core, 3 core, 4 core, how many cores of CPU you have is multiplied by 1 plus the wait time, average wait time, and the average compute time. This will give you the number of threads you want to create. Okay, cool. So with this, we have completed our second question as well. I hope you have understood. If you still have any doubt, feel free to comment and give it a thumbs up if you liked it. All right, let's move ahead. So this is our third question, which says, why is string immutable and what is the string constant pool or intern? It's a very interesting question, and I'll explain you in a very simple way that you can answer it to the interviewer. This question you might have faced many times in interviews, but probably have, difficulty in, answering this. But this is the time your problem is solved. Hold on with me and let me explain you. Give me a chance. So first of all, why is a string immutable? What is the meaning of immutable? We will understand this first, and then we will understand what is a constant pool or intern. So immutable means cannot change. Cannot change. So when we say the strings are immutable, it means that the values of a string cannot be changed. Let me explain this to you with an example. I will change the color. I don't like this color. Okay, let's take a blue color. So basically imagine we have a string s1 which says hello. Okay. And then what we do s1 dot concat and we write world. Now if you do s out s1, what do you think? What is the answer you are getting? Is it hello world or just hello? Let me tell you, the answer is just hello. Okay. Even if I have concatenated a hello with a world, I will not get a hello world because of the property that string are immutable and the value of a string cannot be changed. So this you can also write it in a Java code and you can also get the output. You will get the same output, that you will get only hello. Now why this is the case? Now we have understood that what is the meaning of immutable. All right, the strings are immutable. Now the question is why is this string immutable? Let's answer that. To answer that, just think and just try to answer me that why strings are used, where strings are actually used. All right, if you think it properly, you will understand that strings are actually used to store probably passwords, right? Passwords, or probably some highly sensitive data. All right. So for this reason, string are kept as immutable so that no one can, change it or no one can alter it, right? This can be one reason why string are immutable. What can be the other reason why string are immutable? It is due to thread safety. So just now in our first question we were understanding about the problem that if we have an object, some thread 1 can come and change the value of object, some thread 2 can come and change the value of object, thread 3 can come and change the value of object. So to overcome that, in case of string, what Java has done, Java has made the string as immutable. No one can now change the value. So even if thread 1 will come, he or she can access the real value, thread 2 will come, he or she can access the real value, thread 3 will come, he or she can access the real value. So for safety purpose, for thread safety, string are kept as immutable. Okay, and now it can be shared across these threads without any problem, right? Now the question is, what is string constant pool or what is intern function? All right, let's understand this. Let's change the color for a better readability. All right, let me take green. Okay, so first of all, let me explain you what is string constant pool. It's just a special memory which is inside our heap memory. So if you have seen the RAM, inside the RAM we have two different type of memory. The first memory is called as stack memory and the second memory is called as heap memory. This color is very bright. One second. Okay, so there are two types of memory, stack memory and heap memory. Now inside the heap memory also we have a special type of memory which is called as string constant pool. This is called as string constant pool. All right, Now, what does the string constant pool basically stores? So just now we have written s1 is equal to hello. So basically what it will do, it will take a memory and it will create a new object over here which it says hello. Alright, and let's say if you have s1 is equal to hello, and if you have s2 is equal to also hello, okay, now what do you think? Do we have 1 and 2 both hello? Do you think it will duplicate? No, it will not duplicate. Rather, it will just refer to the same memory location. It will just refer to the same memory location. So since s1 is hello is created, it will just point to this. Now if you again create s2 is equal to hello, it will, rather than creating a new space, it will just point to the same location, and that's it. If you want to create a new space with a hello, you have to do something like this. String s3 is equal to, you have to use the keyword new string, and now if you write hello, this will create a new memory space with hello. So this is how the string actually works, and this is the exact string constant pool, the concept of string constant pool. So if you see, we have a code example over here. So when you say s1 is equal to new string hello and s2 is equal to new string hello, so since this I've used a keyword called as new, so if you do s1 equal s2, it will give me a false value. Why? Because these are both different memory location. But now if you do s1 equal to s1 dot intern, if you write this statement and if you do this, now it will give me a true, because now it will put s1 into the string constant pool. Now it will change the memory address to the same memory address, and it will give you the same address, right? So this is what the entire concept of string constant pool is, and this is why the string are immutable. All right, with this we have understood our third question as well, and we will move to the fourth one right now. So this fourth question tell me that we have to explain the checked and unchecked exceptions. All right, and what are the best practices with try with resources. All right, this is a very common interview question also, and this has been asked in Amazon as well, that you have to explain the two types of exceptions, which are checked and unchecked exceptions. We will understand this in a very simple way, in a very simple manner. All right, first of all, what are exception and why do they actually arise, and how do we handle them? All right, so exception basically, they can come in the code in any form, probably a null pointer exception, an arithmetic exception, file not found exception, or probably class not found exception. But how do we handle? But let me tell you first of all, so the structure of an exception. So it looks like this. You have a try block, or 1 second. Let me just remove this. Before understanding this try and catch block, I'm going to explain you why does an exception arise, why exception is there, okay, why it can happen. Imagine a scenario, you are doing 1 divided by 0. What do you think can be the answer? The answer is infinity. Basically there is no answer to this. 1 cannot be divided by 0. So for this is an exception, because it is not possible. 1 divided by 0 is not possible. Imagine you are trying to access a path in your C drive, okay, some document, something, okay, and you have a file name called as math.xy, okay, and someone might have deleted this file and you are still trying to access this file. What do you think? What should be the answer? The answer will, the program will terminate. The program will stop and give you an error, and the program will not move ahead. Similarly, for 1 divided by 0, if you write this in your program, the program will stop. The program will terminate, and the app will crash. So to solve this problem, we have something called as exception handling. Alright, so exception handling, now what it will do, so in case you know that your file may exist or may not exist, or it might have deleted, so you handle this, that okay, I know that my file can exist or not exist, so for that I need to handle that. So to handle that, you have something like this: try, catch. Okay, now you write all of your risky code here. I don't need this. You write all your risky code here. Your risky code. So for example, I am trying to access that C file of math.xyz. So I will put this statement inside a try block. So what compiler will do? Now compiler know that okay, in whatever is written inside this block can be a success or can be a failure. In case it is a success, let's move ahead and let's not stop the program. And in case it is a failure, then also we will move ahead and we will not stop the program. This is how you should be in your life. Alright, you should always put your things in a try catch block. So coming back to the point, catch, it will catch an exception, E. Okay, so in case the program is success, the compiler will not go inside a catch statement, but in case if the program fail, it will come inside a catch block. Okay, and it will throw an exception. That file, probably you will throw an exception of file not found, and move ahead. Simple. Don't stop the program or don't terminate the program if I'm having an issue or if I'm having an error. This is the use of a try catch block, and this is why it is used for. Alright, now coming back to the question, we have two types of exception. The first type of exception is called as a checked exception, and the second type of exception is called as an unchecked exception. What does it mean? So basically checked exceptions are the one which you know can exist, which you know. So right now, file not found, this is a checked exception because I know that this exception can occur. The file may be deleted or may not be deleted. So this is a checked exception, and we can only handle checked exception. We cannot handle unchecked exception because unchecked exception can come due to code error. Okay, and code error can only be solved once you run the program. What are the types of unchecked exception? It can be a null pointer exception. It can be a arithmetic exception. Okay. And what are the types of check exception? It can be a file not found exception or class not found exception. So these types of exception are checked and unchecked. If you come back, so checked exception, yes, it can be handled and it is checked at compile time. Unchecked exception, it cannot be handled. What are the types of checked exception? Subclass of exception, basically it's a runtime, it's a subclass of this exception, and unchecked exception, it's a subclass of runtime exception. These are recoverable issues. These are programming mistakes. It can be IO exception, SQL exceptions. It can be a null pointer or divide by 0. So this is our fourth questions and we have covered it successfully. Let's move ahead to our fifth question. So here on the screen you can see your fifth exception, which basically says that I have to explain the differences between streams and parallel streams and what are the benefits, what are the pitfalls when you use them. Alright, it's a very cool question. Let me just explain you over here. First of all, what are the streams basically? So basically streams are basically, It's a pipeline for processing data. So initially, when the streams and parallel streams were not introduced in our previous in Java 7 or Java 6, if you want to process certain data, what do? You basically have a list and you use a for loop like this, and inside the for loop you write the logic for your processing and you process the data. But after Java 8, since we have introduced streams, this is the thing that we actually do. So in streams, basically you can directly process the data with the help of filter, map and for each loop. So basically what it does, initially let's say you have a list, and probably list of string, and you have a list, let's say answers is equal to new list, and inside this list you have certain data, and you want to process this data. That you want to, in answer you want to filter out that whatever is the uppercase letter. Let's say in answer you have something like develop, then you have India, then you have probably, let's say, Google, then you have probably, let's say, Apple. Now if I ask you that you need to filter out only those string which are in capital letter, so basically you have to filter out India from this list, what will you do? Initially you can do it with the help of a loop. That is a correct solution, no doubt. But since in Java 8 we have introduced streams, you can do it something like this. So you can have answer.stream and you can apply a filter. You can apply a filter for length as well. Let's say if you want a length greater than 2, 3, whatever you want, you can do that. You can map to a string which are uppercases, and you can also use a for each loop. So this is what the exact stream is, and this is where you use it. Now the second thing is, what are the parallel streams and streams? Now we have two things. The first thing is called a stream and the second thing is called as parallel stream. So let me tell you, both are same and both do the same job. But the only difference between stream and parallel stream is parallel stream can filter or process multiple lists or multiple data flow at a time, since it's a parallel stream. And this is a part of multi-threading. So if you want your CPU to do the work faster, you can use a parallel stream. And if you want to with the help of CPU, if you want to just with one core you want to do the work, you can just use streams. So stream provide a declarative, map, filter, reduce and lazy processing. Stream are lazy processing, whereas parallel stream can speed up the CPU. Non-blocking, and it's a non-blocking operation, and on large data set you can use it. What are the pitfalls? Non-associative reductions, blocking input output inside parallel streams, and contention on shared state. So prefer collectors and pure function. So there are certain functions and collectors which can be used to overcome these pitfalls, right? So with this we have come to the end of this video. I hope you have learned a lot. If yes, I just want you to write a comment that you have learned, so that it helps me to understand that you have watched the full video and you have learned something. Alright, it motivates me to create more video like this. Until then, I will see you in the next video with new set of questions and with new Java concepts. Alright, bye bye, good night, take care.